Good day to you. In this example problem, what we have is we have a closed circuit. And what we're going to want to be looking at this is we're going to want to apply Kirchhoff's rules. So we're going to look at the junction rule and we're going to look at the loop rule. All right, so we want to look at both of those. So what we have here is we have a 4-volt source, we have a 1-volt source, we have a 1 ohm resistor, we have a 2 ohm resistor, and we have a 3 ohm resistor. And what we have is we have I1, I2, and I3. Now I1 as well as I2 in this bottom loop, so this is going to be our bottom loop, the current is going counterclockwise. In the top loop, what we have here is we have an I3, and that likewise is going counterclockwise. And what we want to do ultimately for this problem is we want to find I1, I2, and I3. We want to find values for those three. So if we look at the bottom loop, we're going to go counterclockwise. Now the direction in which you go, it doesn't matter. You could go clockwise if you want to, right? But in this problem, it happens to be counterclockwise. If you go clockwise, you're going to get the exact same problem. All right. So what we're going to do, and I have my notes here so I don't make too many mistakes. All right. So what we're going to do is if we start here, we're going to go up this way, and what we're going to do is we're going to find out that we have a 1-volt source. Now, if we're going from negative to positive, that means we're increasing in voltage, so this becomes equal to 1 volt. All right. As we're going this way and we're going with the current, we're going to be reduced in voltage because of the resistor, so this becomes I2, right, because we're going along I2, and now this happened to be a 2 ohm resistor. All right, so there's a 2 ohm resistor. We continue going on, we come down this way, we're going to run into this resistor, which is going to be a 3 ohm, and we have I1, and once again, we're going to have a reduction in voltage, so this is going to be I1, 3 ohms, right? 3 ohms. Now we're going here, and we're going from a positive, from a negative to a positive, so we're increasing in voltage, so this is going to be 4 volts. Now, because of the loop rule, this is all going to be equal to 0. All right. Now, if we look at the top loop, all right, so we can say the top loop, we said that we're going to go counterclockwise. All right. So there's the top loop. Now, if we look at the top loop, we can start here. All right, we can start this. You can start anywhere you want. You can start on this side, you can start on that side. I happen to start here, and we're going to go counterclockwise. And what we're going to do is we're going to run into this 1 ohm resistor, and there's going to be a reduction in the voltage. All right, so this is going to be I3 because it's going to be the third current times, now that becomes the 1 ohm resistor right there. We're going to then come down. Now, because we're overcoming I2, we're going to have to gain in voltage, and so this becomes a plus I2 times 2 ohms. So this is really nothing more than a voltage and a voltage going back to Ohm's law. All right. Now we're coming around here. We're at this point. We go from a positive to a negative, so that means we're going to be reduced in 1 volt. We're going to fall down a potential because the plus is a higher potential than the negative. And because of the loop rule, this is all going to be equal to 0. Now, at this point in time, what we've done is we're done with the physics. Now what we do is we have to solve a series of equations. All right, so we have to solve a series of equations. Okay. Now we can rewrite this bottom equation. We can rewrite the bottom equation as 1 minus 2I2, leaving out the ohms, minus 1, all right, minus 1. Oops, sorry, not minus 1. Sorry, got ahead of myself. This becomes now minus 3I1 plus 4. All right, plus 4. Now we can simplify this, and this is going to be equal to 0. All right. Now we can simplify this as saying it's minus 2I2 minus 3I1 plus 4, all right? Sorry, plus 5. I can't add. It's too late at night for me. So this becomes plus 5 is equal to 0. Or we could say it's minus 2I minus 3I1 is equal to a minus 5. We just simply move the 5 over there. We can make this all positive now, such it becomes 2I2 plus 3I1 is equal to 5. All right, so now we've rewritten this bottom one. We can look at the top loop right now. So if we look at the top loop, what we have is we have I'm going to erase this 0, get that out of our way. All right, get that out of the way. Just draw a line to kind of sort it. Oops, that's not the brightest. Okay, so this becomes minus I3 plus 2I2 is equal to 1. All right, is equal to 1. All right, and if we wanted to rearrange it, we could have it as 2I2 minus I3 is equal to 1. 1. Now, we've come up with these two equations for the problem. However, there's a bigger problem, right? We have a math problem in that we have two equations with three unknowns, I1, I2, and I3. Therefore, there is not a unique solution to solve this. So we have to come up with a third equation. To come up with that third equation, we're going to look at this junction right here. So I1 goes into this junction, I2 and I3 go out of the junction, so we can use the junction rule right here in that I1 is equal to I2 plus now I3, excuse me. I3. Now, we can substitute this in for there. All right? So what we get is we get 2I2 plus 3 times I1, which would give us 3I2 plus 3I3 is equal to still 5. Right? We can combine this. We get now 5I2 plus 3I3 is equal to 5. Now let's look at this equation right here. If I bring that equation down, I have 2I2 minus I3 is equal to 1. If I multiply this by 3, notice that my I3s are going to cancel. So if I add these two up, we get 5, oops, not 5. We have 3 times 2, which is 6, plus 5, which is going to be 11 I2. 3 times a minus 1 is minus 3, plus 3 I2, which is going to be 0, is equal to 3 times 1 is 3, plus 5 is 8. So our I2 is equal to 8 elevenths, which is equal to 0.727 amperes. So I'll write my I2 over here. 0.727 amps. Okay. Now, what am I going to do next? Well, I could substitute this into I2 and solve for I3. So separate this a little bit. So we now have 5 times 0.727 plus 3I3 is equal to 5. If I solve this for 3I3, it's equal to 5 minus 5 times 0.727. All I've done is I've brought this over to that side, such that I have now 3I3 is equal to, I believe it's 1.36. So now my I3 is equal to 1.36 divided by 3, which is equal to 0.45 amperes. So I now know my I3 is equal to 0.45 amperes. Now, since I know my I2 and I know my I3, I can solve for I1. So my I1 is equal to I2 plus I3, which is equal to, I can just substitute these numbers in, plus my I3, which is 0.45 amperes, and this is equal to 1.18 amperes. So we now have found I1, we have found I2, and we have now found I3.